Okay, we want to find the inverse. How many of you got it? Okay, I showed you 4 steps. Step 1, change f of x to y. Okay? And if you want to just use an f of x instead of a y, you can. Okay, second step is to, we're going to go back up here. Second step is to what? Switch the x and the y. So x equals 2y minus 3 all over 5. Next step is to solve for y, right? And to solve for y, I'm going to have to do a couple things. First of all, I have to times both sides by 5. 5's cancel out, and I get 5x equals 2y minus 3. Okay? And then what do I do to get y by itself? Add 3 to both sides. And that gives me 5x plus 3 equals 2y. Then divide by 2. And we get y equals 5 plus 3 halves. Or you can leave it as 5x plus 3 over 2. And then the last step. What's the last step? Change it to inverse notation. That means replace y with f inverse of x. So 5 halves x plus 3 halves. That is how you find an inverse of a function. Yeah. Remember, this means f inverse of x. Everybody say that. Okay. The reason I have you guys say that is because everybody says that, you know, the f to the negative 1 thingy? And so I want you guys to know that. F inverse of x. Okay. Now, the other one down here. How many of you did that one? Okay. We're going to use red for this one. Same thing. Replace g of x with y. What's next? You guys, what's step 2? Okay, change x and y. Switch x and y, we should say. That's how you find an inverse, is switching the domain and range. So switching the x and the y. Then what? Divide by 3. Those cancel out. I'm going to put the y squared on the left side. Equals 1/3 x. Square sides, right? And I get y equals plus or minus the square root of 1/3 x. I'm just going to leave the square root of 1/3 x. We could rationalize that, but I'm not going to worry about it right now. I want you guys to understand inverses, more importantly. Now, why did I put plus or minus? Because anytime you have something that, when you square like that, it could be the positive or the negative that you're squaring, right? And so, if I had y squared, if I put a number in for y, it could be, yeah, you do, but I'm going to show you something. Do you remember last time we talked about, you guys, we talked about some functions have inverses? Remember that? Okay, and so I'm going to go to a new slide right here. And I'm going to write this one down. What was the original equation right here? G of x equals what? What was it? 3x squared. How many of you guys know that this function actually doesn't have an inverse? Anybody tell me why? Sam? It doesn't pass the horizontal line test, yeah. If you remember right, 3x squared would be a parabola that looks like this, okay? Now, is a parabola a function? Okay, the parabola is a function because it passes the vertical line test. However, its inverse, if we graphed its inverse would look like that. Is the inverse a function? No, because it doesn't pass the vertical line test. So the inverse is not a function. Sam? Not on the quiz today, but they're probably on the test. Okay? But the quick way of doing that, the quick way of checking, you guys, is to see if your original function passes the horizontal line test. If your original function does not pass the horizontal line test, then the inverse will not pass the vertical line test, and it will not be a function. Well, actually what we do is we don't take the whole function. We're going to restrict the domain of this function, JD. This is the part you'll want to listen to. Okay, if I have this right here, once again, I'm going to graph it again right here. What can I only take part of that function? Trayson just said it. I can take part of that function, and then it would pass the horizontal line test, wouldn't it? Okay, well, yeah, let me get there in just a second. But what part of this, let's look at this picture right here. What part of this would I take? The right half, right? I could take the left half, but we usually always take the right side of it. Just take the right half of a parabola. And I'm going to outline that in green. If I took this part right here, now does it pass the horizontal line test? Yeah, and so its inverse, which would look like something like this, would pass the vertical line test. Therefore, you guys, when we solve this and I got y equals plus or minus the square root of 1/3 x, technically, we only wanted the positive of that. We only wanted this part of it. We didn't want the bottom part of that. Remember, the inverse, you guys, is you get the inverse by switching the domain and range. Well, on this first one, if we restrict the domain and we only take this green part right here, in other words, we're restricting the domain to only be numbers greater than or equal to 0, aren't we? So guess what? When we switch the domain and range, the y will only be what? Y will only be greater than or equal to 0. In other words, I only want, for the y on the inverse, I only want everything above the x-axis. And so that blue part would be the only part we'd want. When you switch domain and range, it switches the restrictions you make too. Okay? So do we understand that? Okay. Now, we got to do a couple things. We got to turn in the transformations assignment, okay, because I answered questions. I will be willing to answer 1 or 2 questions on that right now. Okay, Drake and Eli, what do you guys have? Number 8 on the back side, the graph. Oh, the challenge problem, huh? There's some right over there on the cabinet if you want to go through. Who thinks they got number 8 that on the back side there? Cool. What did you get, Jenny? Okay. Guys, Jenny had y equals the absolute value of x squared minus 4, which is that going, you guys? Oh. That looked like a 0. It's an 8, right. Okay. Is it all gone? It might be all gone. No. Right there. Okay. Anybody else get this too? This is what Jenny had. Okay, good. I want to show you guys this because this is really cool, and it might show up on your benchmark test that we're going to be taking. Okay, something similar to this, and we're going to do some more problems similar to this as well. Okay, I want you to know that this is just a composition of 2 functions. I take and make a function called f of x, which is the absolute value of x. And I take another function and call it g of x and say that it is x squared minus 4. What composition would I do in order to get that function up there? Remember, f composed of g or g composed of f. What would I do? F of g of x, yeah. If I did f composed of g of x, that means I'm going to take, which function am I going to put in which function? I'm going to put g into f, right? Well, look, here's f. It's got absolute value signs. I'm going to leave a big blank in there. And in place of x, I'm going to put function g, which is x squared minus 4. Do you see that that's the function right there? Okay. Now, I want to show you the graphs of these two functions. The graph of f of x equals absolute value. Yeah, it does. And well, actually, what I should have just shown you is this one. This one right here is the function that you get when you shift an x squared function down 4 units, right? Now, here's the thing. If all of a sudden you put this one into that one, g into f, okay, now you're taking the absolute value of things, and all your answers, all your y values are going to be what? Positive. See all these y values down here? They are negative. Well, if we took the opposite of them and made them positive, what would it do? It would flip. And that's why it gives that W shape. It's because it flips the bottom of that parabola up like that. Yes. Two hump things? Well, no. Well, you could if you took like the absolute value of an absolute value function, maybe. Try this one. That's a good question. What would be my two functions? Anybody want to take a guess? Well, if one function was f of x equals absolute value of x minus 4, don't you think that would work? And then my second function would be what? The absolute value of x. And then what am I, and which composition do I want to do? I want to put f into g, so I want to go g composed of f, don't I? Now, if I take function g, which is absolute value of x, and in place of x, I put the absolute value of x minus 4, then what's going to happen? Try that. Let's see if it works. Yeah. You got it? Does it work? There's your W. How would you get one that had two humps in it? What? And then a straight line? You would probably have to take the absolute value of some kind of fourth degree polynomial. I'm trying to think. The other thing you could do is take a trig function and do it. Take the absolute value of a trig function. Like sines and cosines go like this. Sines and cosines do that. And if you take the absolute value of them, you get and let's say the x-axis is going through there, it'll flip all those up. Okay? Are you guys trying to stop? Because we want to watch the football game. Because the only way we're going to get to watch the football game is you guys trying to stop. If you're seriously asking, I'm okay with it. Trayson. Huh? I mean, Tyson. Tyson. I have no idea. Look it up. Look it up. Huh? Are you at? Yeah. Go ahead. Yeah. Why did it do what? Why did it do that? The one. No. Someone asked me if we could make it do that with straight sides. And I said the absolute value of an absolute value function. So, okay. So here we go. Is that it? Are we ready to correct the assignment? Was there any others? Or was that it? 7's too easy, Eli. That paper's not due till next time. We're gonna do that in a second. 7? 7, really quickly, you guys. No. It's a reciprocal function. What does a reciprocal function look like? I mean, what's the equation look like? It looks like 1 over x, right? On the back side, right by number 8 we just did, 7. This is number 7. Okay, now, you guys, which way did it move?
Over 4. It looks like it went over 4.
Okay, it looks like it went over 4. So it has what?
It went left 4.
So how do I make it move left 4? Now, you can't just say plus 4, because plus 4 means, and I know some of you guys are saying in parentheses, but a better way to say it is replace x with x plus 4, okay? You replace x with x plus 4. And then how do you get it, what else did it do? How do you get it to do that?
Subtract by 1.
Okay, to move it down 1, we subtract 1. Okay, hey, you guys, in your calculator, and some of you are getting confused on this, when I put this in my calculator, I can write it, when I write it like this, I can do it without parentheses, but when you put it in your calculator, you have to put parentheses around the x plus 4. Okay? All right, we're going to correct this. Okay, we are going to do the following problems. 25. We're going to do the 25th problem, the 13th problem, the 11th problem, the 3rd problem, and the 19th problem. So starting with number 3 on the front, we're going to do that one. Okay. Let me borrow that. This is the front. Number 3 on the first section. Okay. Then we're going to do the 11th problem on the front. That would be 8 plus 3. So the 3rd one on the next one, right? So the 3rd one in the second section. 13 would be the 5th one in that bottom section, right? So we're doing 3, 3, and 5. And then the 19th problem would probably be on the back, right? No, it would probably be the last one on the... Is it the first one on the back? Okay, so first one on the back, and 25 would be the number 7, wouldn't it? Oh, isn't there just 25 problems? Yeah, it'd be the 7th problem, right? First one on the back is 19. Okay. So, yeah. No. You only really need to graph this set right down here on a separate graph. Okay? All right, here we go. You guys. We're going to grade number 3 right here. Okay, everybody go to that one. Number 3 right here. Everybody got it? It should be, the first blank should be 2 units to the right, and then the second blank should be 3 units to the left. Got it? Okay, then we're going to correct number 3 on the bottom part right here. Number 3 right here. Number 3 right there should be an absolute value function that has been shifted down 3 units. Okay? Number 5 should be a parabola that is upside down and been shifted to the right 3 units. So it should look like that. Got it? Number 1 on the front should be, number 1 on the front should be, what does it do? Shift left 1 and down 4? Okay, so it should be y equals x. Four. You got that one wrong. You need to fix that. Okay. Okay, you'll miss 1 point on it. You missed the x plus 1. If you went down minus 3, I'm okay with that. If you're within 1 of 4, I'm okay with that. Okay? And number 7, you guys, we just went over that. Where was it? Where was number? Oh, it's right here. 1 over x plus 4 minus 1. Okay? So everybody should have got that one right. All right, put a score out of 10 on it. Put it on the flapper board. Yeah, staple them together over there. Let me make sure I have staples. Okay, who's got one? It'll work. Okay, I'm going to go JD first. Go JD. Hey, will that one work, you guys? Yeah. How can we tell? Yeah. That it doesn't pass the horizontal line test. If I was to draw a horizontal line, it wouldn't pass it. That means if I was to graph its inverse was like that, and this inverse would not pass the vertical line test, right? Where would you restrict this one so that you could, where would you restrict it so that it would have an inverse? At x is equal to 0. Why there? Because cut it in half, right? And we would only have this half. Does that half pass the horizontal line test? Use what? You don't like my green? I think I have to change it later. That's a good color green. I like that. Oh, you meant not do this whole thing in green? Okay. So, one more time. You guys, here's the absolute value of x. I only want to take everything greater than 0 from here to the left to the right. That means x is greater than or equal to 0. Therefore, I'd only have this part of the graph, right? And that part of the graph passes the horizontal line test. Now you get it? All right, good. Okay, next question. Prove. I'll give you guys all candy if someone in this class comes up with this one. Yep. No, I don't mean everybody has to get it. Just one person has to get it. But everybody gets candy. Prove that the inverse of a non-horizontal linear function is also linear and that the slopes are reciprocal. It says it right there. Read it. Prove that the inverse of a non-horizontal. Now, you guys, if it's non-horizontal function, it has to be it can't have a 0 slope, right? Because horizontal lines have 0 slope. But it can't be a vertical line. Why? Because a vertical line is not a function, right? So it has to have a slant to it. Okay? You have to do a proof that works for all linear functions that are non-horizontal. Okay, work with your shoulder partner and your group and see if you can come up with something. I'm going to pause it for a second. Linear, and that the slopes are reciprocals, right? So, first of all, this is just one example of a function. Yeah, if I found the inverse of that only proves it for that function right there. But it doesn't prove it for every linear function. I want one that proves it for every single linear function. You're on the right track. However, what's the problem with that one is, how are we going to tell if the slopes are reciprocal? Come on, you guys can get this. Should I skip it and come back to it another day? So you have time to think about it? You could probably Google. I don't know if you'd find it or not. Can I try right now? No, we don't have time right now. Okay. You guys give up? All right. I'm going to let you guys think about that. We're going to go on, see if you can get it next time. This is what I want you to do right now. Everybody, graph the function y equals x squared and y equals 2 to the x on the same coordinate axes. Compare the values of the functions over various intervals. Expand your graph and see which one is growing faster. Look at the tables of these functions and see which one is growing faster. We're going to do this one together. So I want everybody to go to your y equals screen. And you're going to put x squared and 2 to the x into your calculator. And you're going to hit zoom 6. Zoom 6. Now, if you look at this, we want to know which one's faster. Well, it's kind of hard to look that way, so we're going to expand our graph. Where do we need to look? Up. How do you move your graph up? Okay. Let's go to, let's say, 100. And let's change the y scale to 10. Let's look at that graph. See if that gives us any information. Which one's growing faster? You can see the exponential is a lot steeper right here, right? Okay, now check this out. I want you guys to learn how to do the table. Everybody go to second and window to set up your table. I want us to start at 0 and increments in 1. Okay? Everybody got that? Now, go to second and graph. And it'll show both functions at the same time, y1 and y2. All you have to do is, if you look right here, when x is 0, the quadratic is 0, the exponential is 1, and then 1 and 2, and then 4 and 4, they even out right here, don't they? And then right here, the quadratic is bigger than the exponential. 9 is greater than 8. But then they even out again at 16, right? But then, all of a sudden, the exponential is bigger at 5, and at 6, the exponential is bigger. If you keep arrowing down, what do you notice? Which one's getting bigger a lot faster? The exponential is. Kind of cool, huh? You can compare those. Which is more valuable than helping you, the graph or the table? Probably the table. Okay, now that you guys know how to do that, I want you to do the same thing with this one right here. Okay, transform y equals x squared minus 12x plus 35 into a form that will help you find the zeros. Transform that into a form that will help you find the zeros. What do I mean? Find the x-intercepts. So what form am I going to transform this into? Not vertex. Factored form. In other words, I'm going to factor that. What do I factor that to be? What does that factor to be? X minus 7 and x minus 5 would work, because negative 7 times negative 5 is positive 35, and you add them together, you get negative 12. How does that help me find the zeros? What would the zeros be? 7 and 5. Are there any questions on that? Okay? That's what it means when I say transform it into. I took it directly off that word. I don't like that word, because when we talk about transformations, we're talking about moving functions around. But it says transform y equals x squared minus 12x plus 35 into a form that will help you find the zeros, okay? And what they mean is factored form. There's another one on there that says transform, again, something like that last one, x squared minus 8x plus, let's say, 13 into a form so that it helps you find the vertex. What form would that be? Vertex form. Do you guys remember how to do that? Completing the square. Whoops. You group the first two terms together. Leave a blank. What am I going to put in that blank? Why 16? Take half of 8 is 4. 4 squared is 16. But what do I have to do out here if I do that? Yeah, I have to minus 16. And then this factors into being what? X minus 4 times x minus 4, which can be written as x minus 4 squared. And 13 minus 16 is negative 3. So where's my vertex? 4, negative 3. Remember, take the opposite of that one. Okay, that's all I'm going to say. Vertex form. Remember vertex form? In the form of y equals a times x minus h squared plus k. If you transfer it in that form, h comma k is the vertex. Remember? Okay, quiz time.